Canada's national anthem, O Canada, was written in French in 1880. In English-speaking Canada, the most widely accepted version of this song has the line, "True patriot love, in all thy sons command." A group of determined women took it very seriously that Canada's national anthem hailed its sons but not its daughters. In January 2018, Canada passed a bill making O Canada gender neutral with the words, "True patriot love, in all of us command." In Canadian society, anyone who was a child before 2018 learned the version referring to our sons. When these same people sing their national anthem at a Toronto Blue Jays game, they are more likely to refer to these sons. Why does this group find it hard to adapt to the new version? Here we see the general law of association of ideas. In humans, our ideas exist in the order in which the feelings existed. In learning the anthem, we repeat it. We pronounce words in successive order from the beginning to end. We experience feelings as we repeat it, and the feelings are successive as well. And when we learn the anthem as children, we are repeating sounds, not words. So when children are singing the anthem, the feelings of the words are sequential, the preceding sound suggesting the next sound. Machines also apply the association of ideas when constructing sentences, and is the topic of today's podcast. In the meantime, if you would like to test this theory, try to sing your national anthem backwards. Welcome to We Are the Machines. I'm Dr. Deitra Sawh. This podcast is for those who want to use artificial intelligence. Through anecdotes and phrases, you will be fluent in AI in front of the executive team and at the dinner party. I explain how machines learn in the context of human learning and arm you with the right questions to be asking the machines or those who are building your business machines. You will sound like an AI rock star by the end of each episode. Let's get started. As you puzzle over Canada O, or for some of our southern listeners in the freely of land, we turn your minds to the linkages you are challenging right now in your own brain. The human behavior in our example is called law of association by psychologists and describes the phenomenon of how ideas and experiences become linked in the mind, how humans are trained to link feelings, words, and events in our brains. Large language models, or LLMs, such as ChatGPT, Gemini, Claude, Copilot, apply the same principles as in your brain when responding to your inquiries. The difference is that the choice of the next word by a machine is not guided by feeling. Rather, the machine calculates what word follows the next word, most often based on all of the sentences recorded online. When you type your prompt into your LLM, it does the same thing as a Google search, combing the internet for keywords and phrases. Then it constructs sentences based on how often those words occur together in a sentence from the compendium of internet data. Colloquially, the machines call this guess the next word, which is conducted solely on the basis of the probability of the next word occurring. LLMs are considered to be generative AI because it is creating content. It's like when you write found poetry, pulling words or phrases from already published sources, refashioning and reordering these words, and then present as a poem with new meanings. The machine follows the same path, using calculations of likely words. Let's look at an example. Which sentence is more common in English? Ice cream I like? Or I like ice cream? The latter, of course, as your brains automatically detected a discontinuity in the former phrase. The machine looks at all of the sentences about ice cream and I like available online and will produce for you the one that occurs the most often. It does not have the sense to say, hey, that doesn't sound right, like when you do when you sing O Canada backwards. It simply refers to a standard set of sentences and checks whether sentences with I like begin or end with that phrasing. So how can you harness the power of LLMs knowing that the response is dictated by the probability of words in a sentence? Firstly, you can write better prompts. a concept called prompt engineering. By carefully selecting the words in your questions, you can guide the LLM to the type of response you want. For example, asking the LLM, write a resignation letter, and write a letter saying I quit my job produces different responses. Because the word resignation is associated with professional writing and I quit is associated with more abrupt language, the tone of the response is based on how you prompt the LLM. Secondly, when hiring, you can spot machine-generated resumes by identifying terms that are frequently used together for that role. In management roles, you often see words like impact, inclusive, driven, empower, words that could easily be generated by an LLM. I suggest that you base your assessment of the resume on everything but those associative terms to ensure you are hiring a qualified human. And now a plug for humanity. Today you learned how your brain is associating words and then creating sentences. Let's talk about how you write. At a retirement party, an executive said that he wrote his speech, and after reading ChatGPT's version, he said, "Yeah, that sounds like me." So now we are being conditioned to believe that our individual voice is what the machine outputs. Meanwhile, the machine's output is based on the likelihood of words forming a sentence after being trained on his speech. So the executive is really saying that his speech sounds generic. The more we use the machines to shape our communications, the more streamlined our writing becomes, converging towards standard phrasing provided by LLMs. In this way, we are becoming the machines as we train the machines to become like us. We'll see you next time on We Are the Machines. I'm Dr. Deitra Sawh.